Okay, to continue where we left off, we're going to select the wheel. We are in the Geometry Nodes tab, and we are going to add a new geometry node setup. So let's go ahead and hit 0 on the number pad to look at the wheel through the camera. And let's just review how geometry nodes work. Here on the left, we have the group input. So whatever the original object is, that is this information. Here on the right, we have the group output. So if I unplug this, there's no information going to the output, so we have nothing in the scene. Now let's add a transform geometry node, and we're just going to plug that in here on the right next to the group input. What we want to do is control the rotation of this wheel, and it should be, for mine, it's going to be Y, and I think it should be Y for you also. If not, you can, well, we don't want to change that. You can see which axis it is rotating on. But I'll say if it's not Y, you probably forgot to apply the rotation. So try that and see if that fixes it so this spins correctly on the Y axis. Now, we only want to control the Y value. And when we bring in information in a single line to this, it's going to be pulling in all three. So we need to add a combine XYZ, plug that into the rotation. So then we can manually change the Y by plugging into just this center socket, and X and Z will not be affected. Okay, so now that we have that, we're going to be adding several nodes. So I'm going to take the group input and move that to the left quite a bit so I have plenty of room. So to do these calculations, we need information from two things. We need information from the wheel, and to get that information, we are going to add, I think it's called, let's go Shift A, self object. And that's going to basically take any information about our object, and it's going to be the same thing coming from this node. I think it's a little strange that we have to use another node to get information from this, but the way they have it set up, that seems to be what we need to do. Next, we're going to add, hang on just a second. Sorry, we're going to add an object info node and put that here next to our self object. So we're going to plug in self object into the object, and that's going to get the scale, which is the number that we need. The scale is going to tell us the diameter or the distance from one side to the other of our circle. Next, we're going to make a copy of the object info by hitting Shift D, moving that up, and we're going to pull this information over to the group input. And when I do that, it's going to show that information here. Now we want to name this so it's a little easier later. So I'm going to press N, and we have the group input. We have this yellowish orange circle, which says object. We're going to change that to train path. So when we add this to our train scene, we want to very easily be able to come here, select our train path. In this case, it's going to be the Bezier circle. And this will be what we need to do the calculations. So we want to get to this really easy without having to go into geometry nodes. So we have our path and we have our wheel. The thing that we need to know about the path is how long it is. So we're going to hit Shift A and search for curve length. And we're going to put that next to this top object info, which is our curve. We're going to plug in the geometry into the curve, and this is going to give us the length. If it's 30 centimeters, if it's 20 miles, whatever it is, it's going to give us that distance. So we will come back to the curve object and the length of it in just a second. Let's go ahead and switch back down to our train wheel information. The thing that we need is the scale. And if we look at our wheel, X, Y, and Z are all 1. But when you look at the dimensions, the thickness is 0. So on your train wheel, the X and Z are going to be the 2 numbers that we're going to look at. It doesn't matter which one you pick. It is important that you apply the scale on your train wheel later, so that X or Y represents how far across you are on the circle. So when we get to the train wheel, we'll double check that that's correct. But keep in mind, you need a number that represents how far it is from one side straight across to the other. Okay, so let's do this because we're going to have a lot of nodes, and it's possible that you might make a mistake and you might need to go back and figure out what went wrong. So I'm going to name these a little bit differently. So that way, if you get stuck along the way, it will be a little easier for you to find out and double check mistakes. So we're going to rename this by selecting it. We have this panel open. If you don't have that open, the letter N will open it. We're going to go to node, and it says object info, and I'm just going to put dash wheel. So I know this is the information for the wheel. I'm going to select this one, and we're going to name this one object info. We'll just name it train path. Oh, that's not showing up there. I'm sorry. You have to put it in the label to get that to change. So I'm just double clicking this, hit Control A, Control C to copy, and then you can come down there and paste it. So let's go back to this. Control A, Control C to copy, then Control V to paste. All right, so this already tells us that this node is getting the length of the curve. So let's go back down to the object info wheel. We need the scale of either the X or the Z. So I'm going to hit Shift A, and we're going to get a separate XYZ because the scale has X, Y, and Z attached, and this one string has all 3. I only need one of them. So with that connected, let's select the separate XYZ. Let's come over to the label, and let's just put X equals diameter. I can type today. Okay, so moving on. When we looked at the roll of tape and we had the ribbon that wrapped around, when you go around the entire distance once, that is called the circumference of a circle. That's just the distance if you go all the way around the circle one time. The formula to find that is pi, or 2 pi r. So you take pi, which is 3.14, and a few other numbers. I'll look it up here in a second. You take the radius of a circle. The radius is half the diameter. So if you had a dot in the center of a circle and then you drew a line out, that would be the radius. So the number of pi, 3.14, times the radius, which is half the diameter, times 2 will give us the length around the circle one time, just like that piece of blue shiny paper showed me the length of the circle. So we're going to do a few math nodes to get the different pieces and do that equation for us. So we know that X is the diameter. I don't need the diameter. I need the radius. I know that the radius is half the diameter. So if you're looking at my circle, the diameter is all the way across. The radius is from the center out. So we're going to add a math node. We're going to go to divide. X is our diameter, so X is going to be the number on top. We're going to divide that by 2. So let's go ahead and label this radius is the diameter, back and type, divided by 2. So if you were to forget or mess something up, this tells you exactly what should be happening. The radius is the diameter divided by 2. All right. So let's just straighten this up a bit. Okay. We're going to hit Shift A and add another math node. Our radius is going to come into this. And what we're doing here, the radius times pi, Pi, not P-I-E. So not the pie you eat, the mathematical term pi. So this will be multiplying. So the radius times pi. So this box is finding the radius. It's giving us that number. We're going to type in the value for pi. So we're going to type in 3.14159. So 3.14159. Now, most people go to 3.14, and I'm not really sure how far down we need to go on pi to make it spin well, but just to be safe, we're going to go a few digits past 0.14. Okay, so this box is taking our radius times pi. And I cannot type today. That's not radius. That's radius. Next, we're going to add another math node. And this will be a multiply. And radius times, I'm just going to put the asterisk pi, then times 2. So this gives us the radius times pi. We'll plug that into the top value. Make sure this says multiply. And it's going to be multiplied by 2. So these math nodes give us the length from one point all the way around to the other point on the circle. Okay, now we're going to get back over to our curve, and we're going to be using the length of the curve for the next step. So I'm just going to move that over so that way it's right above this, so we know that these two are related here in the next step. So we're going to add another math node. We're going to set this next to those, and we're going to, hang on just a second. Okay, just double checking my notes. I don't want to miss a step and confuse you all and have to go back and forth. I would much rather get it right the first time. So we'll go nice and slow. So we're going to divide. And what we're doing is dividing the length of the track by the length of the circumference of the circle, that distance around the circle. So if you think back to my example of the roll of tape on the piece of paper, I had a line on the paper that was 32 centimeters. The circumference of that roll of tape was 32 centimeters. So that means that if I took 32 divided by 32, I would have 1. That 1 means that the wheel has to turn around one whole time to go from the start to the end of the track that we drew on the paper. If the track was 64 centimeters, 64 divided by the circumference, which is 32, means it has to go around 2 times. So that's what these two nodes are doing. It's telling us how many times does this circle have to spin to go all the way around this path. Let's go ahead and name this so we know what it's doing. This length of track divided by the circumference, circumference of the wheel. I'm not going to double check your spelling, so if you misspell it, it's okay. So the length of the track divided by the circumference of the wheel. So that is the purpose of this node. And I accidentally typed that in the wrong thing. So let's just select and copy that. And let's paste it in the correct area. And then I'm going to delete this node out, and it will go back to the name. So we have the curve length. We have now correctly labeled. length of the track divided by the circumference of the wheel, which is this. And we might just put this, if you look at this node, radius times pi times 2, let's just put equals the circumference, circumference. So that way, if something goes wrong, you kind of know what parts to look at, and you kind of understand, hopefully, what each box is doing, each node is doing. Okay. Let's go ahead and add another math node. And this one will be multiplying. And let's go ahead and give it the label. This one is going to tell us the number of times, I've got my notes, so I'm typing from them. The number of times the wheel should turn by 360 degrees. Okay, so if you think back to the roll of tape example, for the roll of tape to go from 0 to 32 centimeters, it had to turn around one time. That one time was 360 degrees. Our rotation values are in degrees, so we have to convert how many times the wheel will go around into degrees, and that will control how fast and the wheel will be turning. So we're going to take the number of times that the wheel will go around the track. Let's just say it's 1 times 360 degrees. So if you think back to my example with the roll of tape, if the track was 32 centimeters, the wheel will have to turn 360 degrees. If the track was 64 centimeters, the wheel will have to turn twice, which is 720 degrees. If the track was 96 centimeters, the wheel would have to turn 3 times, which is 1080 degrees. And if the track was 128 centimeters, the wheel would have to turn 4 times, which is 1440 degrees. So this is telling us from start to finish how many degrees total the wheel has to keep turning. Okay. Okay, we're getting close to being done. Let's go ahead and take our group input and move it temporarily just kind of closer. We're going to plug in a couple of things so that we can access them from the geometry nodes driver. Geometry nodes properties panel settings. So we have our group input up close. We are here at the number of times the wheel's going to turn 360 degrees. Let's add a math node. We're going to put that here, and this is going to be a multiply. We're going to take this number and plug it into the bottom. Then we're going to pull this value to the main settings that we can get to. So we have a value here. We're going to name that value. Let's go to the group input. We're going to go to the group tab. We can go down to the names of the sockets. We see value. Let's click on that and change that to paste driver from train's location on the track. Let's change that train's percentage on the track. Okay, so let's take a second and let's select our empty cube. Let's open the properties, and letter C is the percentage of the train of track complete, I should say. So that means that if, let me set this up, our train starts at frame 1 and it ends at frame 100, which we have here, that it will go all the way around exactly one time. So here's 0% of the track, and after 100 frames, it will be 100% of the track. At 50 frames, it will be 50% of the track. Okay, so this number is what we'll be pulling in later as the thing that tells the wheel where it's at on the track. Is it at 1%, at 25%, 50, 75, or 100%? And this will tell the geometry nodes where it's at on the track and how many times it should have turned at that point. So let's go ahead and select the wheel. And we have that labeled so that when we look here in the properties panel, it's named so we know what we're looking for when we do our train scene. In case you forget, everything hopefully is labeled very clearly. Okay, we need just one more node or one more math node and we'll be finished. So let's do Shift A, math, and we're going to add this, and this will be a multiply. And let's go ahead, and I forgot to label this. Let's label this one so we know what it's telling us. So we have the number of times. I've lost track where I'm at. Here we go. Let's switch this to nodes. So this is the number of times the wheel turns by 360 degrees. This next math node is going to be the percentage of the track completed. And this will plug in to the top. Actually, let's plug it into the bottom. And we're just going to move this up a little bit. And this is going to be our wheel direction control. So depending on some various factors, your wheel may spin the wrong direction. And instead of trying to go back and fix all this other stuff, we're just going to make this where we put a +1 or -1, and that will change the direction that the wheel spins, making your life a whole lot easier. So we're going to take this value, plug it into the socket of our group input. Let's go to the group tab. Let's go to this new value. And let's just call this change wheel direction by using 1 or -1. That way it's pretty straightforward and you will know what you're typing. So it does need to be either 1 or -1. If you have anything else, it's going to mess with the speed of the wheel. So keep that in mind. Okay. So you have that named, we have it connected. So now we want all of this stuff to control the Y rotation of our wheel. So we're going to plug this into Y, and you can see that my wheel moved because those numbers are now taking over and controlling it. Okay, last, we're going to see if this works, and hopefully it will. Let's select our cube. And like we pointed out a minute ago, we're looking for letter C, the percentage of track complete. That tells us how far the train is along the track. Is it at 20% or 50%, whatever. We're going to right click and let's just copy this as a new driver. Let's go back to our wheel. Let's look at our notes, paste a driver from percentage on the track. So we're looking at this value. We're going to right click, paste driver. So now where the train is at, we'll come to this. This will tell Blender how far the wheel is along the track and how many degrees it should have turned at that point. So let's hit 0 on the number pad. So we're looking at, let's hide that, the side of the wheel, and let's hit play. And you can see that our wheel is turning. So let's see if it does change speed when we adjust some settings. So let's select the empty cube. Let's open our property shelf. And if we increase how long it takes the train to go around the track, our wheel should go slower. So let's change this number to 200. And nope, I did something wrong. Hang on just a second. Okay, I was just double checking something. So we didn't do anything wrong. What happened is this is such a small circle that the speed was kind of hard to predict or to analyze. So let's go back and change, make sure you have the cube selected. We're looking at B. Let's make this a really large number like 5,000 and hit play. Now your wheel is turning very slow. So if you're looking at this from the side, that looks kind of what you would expect. It's barely moving, so the wheel is barely turning. Let's change this to 2,500. Now the wheel is going a little faster, and I am going to change our end frame so it'll keep playing. So that looks like the speed you would expect for a wheel going that slow around the track. Let's make it 1,000. Make sure that looks okay. So now it's moving faster, so the wheel is turning faster. Let's do something like 500, so it's going faster around the track. And now it looks like that is correct. Okay, so this should give you a setup so that your wheel will turn correctly. So let's go ahead and make these scenes assets so that way you have them all ready for the train project. So let's start with our wheel, and we want the geometry node set up. So let's name this wheel rotation geometry nodes setup. Of course, you can name it whatever you want. I always tell you what I'm naming it, but you're more than welcome to do your own naming conventions. But this way, if you name it like I have it and I mention it, we're on the same page. All right, so now that we have that, let's right click and mark as an asset. You'll see this little blue icon with looks like library books. So we know that is now an asset. Let's select our all of our train controllers, and let's just put those in the collection. So I've selected the cube, and then which is train 0-engine, and I'm just going to select the other 4. Press the letter M to move to collection. We're going to make a new collection. I'm just going to call this train controller collection, and then create. So all of these are part of this collection. So I'm just going to condense that, and then I'm going to right click on the connection and mark the collection. Right click on the collection and mark as asset, and you'll see the little library book icons near that. So let's go ahead and delete the camera, because sometimes other objects come in with it when you move something in that's an asset. I am going to delete this circle because that will sometimes come in. And let me check one thing real fast. Okay, let's just leave our wheel shape. I think if we deleted it, this would still show up, but I don't want to go through the process of opening and testing a file right now, and it won't be that big a deal to switch it out. So we're just going to leave that wheel and that. So that should be everything we need to pull into our train scene, to set up our train, to get our train moving around the track, and to make our wheel spin correctly.